It's time to go behind the pump panel and understand how the waterless discharge relief valve system operates. The waterless discharge relief valve system meets and exceeds NFPA 1901 standard for automotive fire apparatus. This safety system provides sensitive pump control and is designed to protect firefighters from sudden pressure surges resulting from changes in discharge flows from the fire pump. For example, with the discharge relief valve off, if you're operating a pump with 3 discharge lines flowing 100 GPM each, and 2 of the lines are shut down, the entire 300 GPM that the pump is pumping will now be forced out of the last remaining open discharge. This will result in a significant pressure rise on the last remaining open discharge because you're now forcing 300 GPM through one opening instead of 3. Designed with a built-in memory, this system has a wide continuous range of pressure control from a minimum of 75 psi to a maximum of 300 psi, depending upon pump performance characteristics. Its unique design allows the system to be taken out of operation without disturbing the pressure setting. This allows the apparatus operator to leave the system at a preset, ready-to-use pressure setting. The waterless discharge relief valve system consists of 2 main components. The first is a panel-mounted pilot valve, which hydraulically controls the operation of the relief valve system. The second component is the discharge relief valve, which is mounted to the discharge and intake fittings. The discharge relief valve body supports the internal components of the discharge relief valve. 1. The main valve is made of bronze and opens and closes based on the position of the discharge pilot valve control lever and the current discharge pressure within the pump. As the main valve opens, excess water pressure is bypassed from pump discharge to pump intake. The purpose of the main valve spring is to assist with maintaining the main valve open when in operation and hold the main valve in a closed position when the centrifugal fire pump is not in operation. This minimizes the potential for damage to the seat and main valve as the apparatus is traveling from destination to destination. 3. The actuating rod is used to control the indicating lights. The actuating rod spring returns the actuating rod to the closed position as the main valve closes. The pilot valve has 2 controls, one to adjust the discharge relief valve operating pressure, and the second is an on-off control used to place the relief valve system in or out of service. 1. The pilot valve handle control is used to adjust the operating pressure that the discharge relief valve opens at. Turning the handle clockwise increases the discharge pressure, and counterclockwise decreases the discharge pressure setting. 2. The pilot valve spring regulates when the pilot valve will open based on the desired operating pressure for the discharge. The pilot valve will remain seated until the discharge pressure exceeds the spring tension. 3. The pilot valve strainer assembly is removable for ease of servicing. It filters water as it travels through the pilot valve and discharge relief valve circuits. It also contains a 0.035-inch orifice that allows water from port 1 to pass through the strainer and orifice into port 2 of the pilot valve assembly and then into chamber B at the rear of the main valve in the discharge relief valve. 4. The 4-way valve handle on-off lever directs water flow based on its operating position. 5. Discharge relief valve systems are equipped with indicating lights the pump operator can use in determining what the current position of the discharge relief valve is in. The amber light indicates the discharge relief valve is open or relieving the excess water. The green light indicates the discharge relief valve is closed or the discharge pressure is below the pressure the pilot valve assembly is set at, or the pilot valve is turned off. 6. The 4-way valve directs water flow based on its operating position. We will identify the water flow for the various operating modes momentarily. By selecting the off position, the pilot valve assembly places the discharge relief valve out of operation by hydraulically holding the relief valve closed. This position is used when discharge pressures greater than 300 psi are required. In this mode, water pressure from the centrifugal pump enters port 1 and travels through the 4-way valve and into port 2. From port 2, water travels to the backside of the main valve to chamber B. At the same time, water leaves the discharge manifold of the centrifugal fire pump to the face of the main valve within the discharge relief valve assembly. At this point, the water pressure at both ends of the main valve is equal. Since the valve diameter is greater at the backside of the main valve, the total force applied is greater than that found at the face of the main valve. Therefore, the valve remains closed. When the pump operator selects the on position, the discharge relief valve system is in a ready position, and at this point, the water pressure is less than the pilot valve assembly is set at. In this mode, water pressure from the centrifugal pump enters port 1 of the pilot valve and travels through the four-way valve and into port 2. From port 2, water travels to the backside of the main valve to chamber B. At the same time, the water leaves the discharge manifold of the centrifugal fire pump and enters the face of the main valve. At this point, the water pressure at both ends of the main valve is equal, and the main valve remains closed. When the pump operator selects the on position, the discharge relief valve system begins in a closed position. When the pump discharge pressure at the pilot valve exceeds the compression load of the pilot valve spring, the pilot valve unseats, and water is allowed to escape through port number 3 to the intake side of the centrifugal pump. A regulated amount of water that was previously trapped in the circuit of port 2 and chamber B also passes through port 3 to the intake side of the pump. When this occurs, the force exerted on the face of the main valve now exceeds that on the back of the main valve, and the main valve opens. When the pressure at the face of the pilot valve exceeds the compression load of the pilot valve spring, the pilot valve will only open far enough to allow the pressure to equalize. When this occurs, the main valve will only open far enough for the excess water to dump into the intake fitting. Once the discharge pressure drops below the compression load of the pilot valve spring, the pilot valve will reseat and stop the flow through port 3, allowing discharge pressure to build up in chamber B and reclose the main valve.